Okay, this is second semester math, 7th grade, unit 2, lesson 5. Okay, how do you find the square of a number? And so throughout the day so far, students have been having a hard time with that. How do you find the square of a number? The square of a number. How do we find the square of a number? What does it mean to find the square of something? Yes, Teray? You have the power of 2, which means you're multiplying the number to itself, right? So the two factors in the product are the numbers, right? So that's what it means to square something. So if we're trying to find the square of a number, it's a number, but we don't like to say a number. We say the number is the base raised to the exponent of 2, or second power. Okay, so just like we say square, we're really saying second power or raised to the exponent of 2. For number 2, what is the base of the question of problem number 2? What's the base in that example or that question? What's the base? 8 is the base. For number 3, what's the base? 12 is the base. For number 4, what's the base? 2. Which 2 are we talking about? Superscript 2 or the big 2? Big 2, very good. And number 5, what's the base? 7. Who can tell me the answer to number 2? 64. Now, what I need you guys to think about is 8 to the second power is really saying 8 times 8. So the two factors are 8. And the product of those two factors is 64. For number 3, who's got that one? Jose. 144. So 12 to the second power is 12 times 12. And that result is 144. Number 4. Go ahead, Justin. 8 equals 4 because 2 raised to the second power is 2 times 2, and that equals 4. And number 5, who's got number 5? Yes, India. That is 49 because 7 to the second power is 7 times 7, which is 49. Now these are all perfect squares because the base is a whole number, a whole positive number, a natural number. Got it? I think yesterday I said integers. That was actually incorrect. It's a natural number, and I'm going to show you guys what I'm talking about in a moment. So yesterday we learned about a new type of number. What was that new number we learned about? Irrational numbers is the classification, but what was the number specifically that we talked about yesterday? Pi, right? And does anybody remember the definition of an irrational number? Because that's the type of number that pi is. What's the definition? Bokhar? It's a non-terminating decimal or number. It doesn't have an end to it, and
it does not repeat.
There's no repeating digits. Okay? So let's try to get that mentally straight in our minds today. All right, so we'll see some more examples. So I'm going to read this since I want to put this on the class channel. What you'll learn: to find and estimate square roots and to classify numbers as rational or irrational. So now we need to be able to recognize the difference. Okay, our new vocabulary: perfect squares, square root, irrational number. Okay, why learn this? If you know how the area of if you know how to find the area of a square, you can find its square root to find the side lengths. You can use square roots when you install flooring. A number that is a square of an integer is a perfect square. For example, the square of 2 is 4. So 4 is a perfect square. The inverse of squaring a number is finding a square root. The symbol square root in this book indicates the positive square root of a number. Now, if you notice, this should look familiar to you. Does this look familiar to you? You guys get to use this every time we take a what? Quiz or a test. And most of you are to the point where I have this figured out. Okay? It's kind of like a security blanket for some of you. It's nice to have there. It's like it eases a little bit of anxiety, but hopefully by next year you won't even need this. If you notice the numbers down the diagonal, these are all what kind of numbers? We just mentioned it. They're all perfect squares. So notice the first perfect square, the smallest perfect square we have is 1. Isn't 1 to the second power? If we take the square root of 1 to the second power, what is that? It's 1. Square root of 2 to the second power is 2. So square root of 4 is 2. And then if we go on, these are all the perfect squares. Now, if you guys can really quickly, this is what we did yesterday in the warm-up, answer these problems. And it shouldn't take you more than 30 seconds. So really quickly, take 30 seconds, jot this down. And I'd prefer that you show what's happening. Remember, the inverse operation of squaring something is the square root. Yes. So square root and squaring something, they're opposites. They cancel each other out. So what's the square root of 49? How can I rewrite 49 so I can get something to cancel out? 7 to the second power. So if I take and rewrite 49 as 7 to the second power, my second power and my square root, those cancel each other out, and that just leaves me with 7 to the second power. You guys remember that from yesterday? We're good? Okay. So 64. Who's got the square root of 64? How would I rewrite the square root of 64 so I can cancel something out? Bokhar in the back? Square root of 64 is the same as 8 to the second power. And we know that 8 to the second power, my exponent 2 and the square root symbol, those cancel out, leaves me with just 8. Okay, who's got the next one? Square root of 81. Square root of 81. Somebody I haven't heard from yet. Lopez, what's the square root of 81? How would I rewrite that so I can cancel something out? Very good. So the square root of 81 is the same as 9 to the second power. So if we have 9 to the second power, we know that my exponent of 2 and my square root cancel each other out and leaves me with just 9. Okay, and then the last problem. Square root of 225. Who's got this one? Miriam, go ahead. Right. I can rewrite this as square root of 15 squared, which is just going to equal 15 because my square cancels out with my square root sign. There we go. Any questions? Are we good? All right. Now, I had a couple classes, some students were asking me, well, Mr. Hedley, how do I find square roots of numbers that aren't perfect squares? Well, those numbers are going to be irrational for the most part, and we can estimate those numbers, those values. All right, so let me give you a strategy how we'd estimate numbers that aren't perfect squares. So first of all, let's go back to what was said in the warm-up, or in the beginning of the lesson. A number that is the square of an integer is a perfect square. For example, the square of 2 is 4, so 4 is a perfect square. So this is really what's important right here for what we're about to cover. If you know how to find the area of a square, you can find its square root to find the side lengths. Okay? That's what we're about to do. So I want to emphasize that right now, because think about that while we go to the next example. So, do you see this box right here on the left? What is the width of the box? How many blocks? There's 5. What is the height of the box? 5. What is this shape? It's a square. How many boxes make up this square? 25. So what I just showed you in the first slide, if you have an area and you take the square root of it, you get the length of the square and the height of the square, which are equal. That's what makes it a square. So for 36, what would be the length of this box? It's 6. And the height of the box is also going to be 6. And the area is 36. So if we take the square root of 36, we know the length and the width of the square. Got it? That's what makes them a perfect square. Okay, so how do we go about estimating this? So let me give you a strategy. We're trying to find 33. If you notice, 33 is going to be greater than the square root of 25, and it's also going to be less than the square root of 36. Does that make sense? Okay. So let's figure this out. You saw over here, we figured this out. Square root of 25 and 5. Square root of 36 and 6. And now we got this other thing right here. 5 and 5/10. That's halfway between 5 and 6. We're going to try to figure out which interval square root of 33 sits. But I need to find out what is the square of 5 and 5/10. So what did I just ask you guys to do? If I said find the square of 5 and 5/10, what did I just ask you to do? Multiply. What am I asking you to multiply? I heard it. 5 and 5/10 to what? To 5 and 5/10. I'm asking you to multiply 5 and 5/10 to itself. So let's square 5 and 5/10. Tell me what the answer is going to be. Five times 5. 5 times 5 again, plus the 2. Okay, before I multiply the next digit, I got to put a placeholder. And then it's just going to be the same digits again, 5, 7, 2. I'm going to add it all up. Now I got 5, 12, 10. Where's my decimal going to sit? Between the 0 and the 2. So I can say that this is equivalent to the square root of 30 and 25/100ths. Now, which interval is this going to sit between? Is it going to sit between this interval or this interval? Is it between 5 and 5.5, or is it between 5.5 and 6? Very good. So we're going to say that its square root of 33 is on the right side of the interval, and it's about halfway that we're going to estimate. What's halfway between 5.5 and 6? What's halfway there? No. How about we use 5 3/4 or 5 75/100ths? Now here's what I need you to do. I gave you guys the calculators. I want you guys to, first of all, let's check and make sure we know how to use our calculators. So here's the first thing we're going to do. Turn your calculators on. Hit the red all clear button. And now what I want you to do is I want you to hit number 6. So you should have in your window of your calculator number 6. Now,
Mr. Evans, if you're in the building, could you please radio Mr. Baker? Mr. Evans, if you're in the building, please radio Mr. Baker. Thank you.
if you look at the mode button, do you guys see the mode button at the top? Look to the right of the mode button. What do you see there? An x to the second power, right? So in the window, you've already told the calculator what x is. Now what I need you to do is hit that button. What just happened? You got 36, which is what of 6? You squared 6. Do you guys understand? Now that's one way to do it. What I want you to do is I want you to hit all clear again. Now what I want you to do, I'm going to show you another way, because that's a button for squaring it. But what if you have other exponents? So let's just test this out. Hit 6 again. Now what I need you to do is look above the button. That's a red C. And do you see the x raised to the y? Well, in the window is already your x, the number 6. So hit the button. Now you have to tell it what y is. So can we make y the power 2? Let's hit number 2. Okay. Now that we told it what y is, we're going to say calculate it. So we're going to say equals. What do we get back? 36. So now you guys should know how to find the power of any number using the calculator. But here's what I want us to do right now. I want us to figure out how do we find the square root of something. Now if you look back to the button x to the second power, do you see what's written in yellow just above that button? You guys see the square root symbol above it? That's not by coincidence. Those two things are opposites of each other, and that's why they grouped them that way. Well, how do we make the calculator find the square root of something? So here's what we're going to do. Can you put in the window 36, enter 36, and now what I need you to do is to the left of the mode button, do you see the button that has nothing written on it? Do you see above it? What's it say above it? So I want you to hit that button, because now you're telling it whatever button you hit, that button now is going to function like the yellow writing above the button. So hit x squared now. What did you guys get back? 6. So now you took the square root of 36. Do you guys see how I take the square roots now? Now what I need us to do is find the square root of 33 to see if our estimate's close. So hit all clear, punch in 33, and now I need you to take the square root of 33. What did you guys get? 5.744562, and it goes on forever because what kind of number is this? It's an irrational number. There's no repeating digits. So we were pretty close, right? So in our calculator, we got 5.744556, 4, 7, and it continued on. But I would say that was a pretty good estimate for what we just did, right? Okay? So do you guys understand the strategy to estimate? Now, if I wanted a better estimate, I could have split these two things in half and continued to narrow down and get closer to what the value is. Okay? So we can keep using that method of splitting the intervals and testing which side of the intervals. Now what I need you guys to do is I want you to estimate the square root of 3, but I don't want you to use the calculators. So put your calculators down. Can someone walk us through how do we estimate the square root of a number that's not a perfect square? Anybody remember how we just did that? Bokar, you got an idea? Oh, those numbers, you might be able to use those numbers. Maybe, maybe not. We've got to figure out our interval. What intervals do we want? Are we just going to pick any interval? What interval are we going to choose? What square root would you use? Well, we're trying to find the square root of 3. What's that? We're trying to find the square root of 3, right? So think back to what we just did. What would be some square roots that we'd want to use as our intervals? 4 and 2? Okay, let's try. So 4, but is 2 a perfect square? Can we use 2? Is 2 a perfect square? No, we want our intervals to be perfect squares. So 4 is 1. Is there another interval that's near square root of 2 that's a perfect square? Think back to the diagonal on my multiplication chart. This is like the easiest one out there. 1, the square root of 1. So if I took square root of 1. What is the square root of 1, by the way? 1. What's the square root of 4? 2. Now, what's halfway between 1 and 2? 1.5. And if I squared 1.5, what would be a number that I can use above the number line? 2 and 25 hundredths? Okay, so if I take the square root of 2 and 25 hundredths, it'll give me 1 and 5 tenths. That's correct? You sure? Nobody checked it really quickly? It's 2 digits, decimal place to the tenths place. Check it really quickly. Okay, you verified it? Okay, now we have to figure which side is square root of 3 going to be. Is it going to be between the interval of 1 to 1 and 5 tenths, or between the interval of 1.5 to 2? Look at the, that's why we had to square 1.5, right? So we need to be able to compare the same type of numbers, square roots. So which side of the interval is it going to be? Don't use your calculators. You're not going to have them next week. Remember, it's got to be between. It's got to be greater than 1 and then less than the other one. So we split the interval into 2 intervals, right? And 1.5 is the split. So which side of 1.5 is it going to sit on? Miriam? You said the right. Why? Right, it's greater than. So it's going to sit between here. And what's halfway between 1 and 5 tenths and 2? 1.75. Now, can you guys take out the calculator and see if we estimated well? Was it a good estimate? Take the square root of 3 and tell me what you get.
1.7320508088.
So using the calculator, you said 1 point what?
732050880.
And it keeps going, right? Would you say that was a pretty good estimate? I think that was a pretty good estimate. Now let's estimate the square root of 5. So what am I going to use for my intervals for the square root of 5? What are the closest perfect squares around the square root of 5? Square root of 4 and what? What's the next perfect square after 4? 9. So square root of 9 is what? 3. Okay, what's halfway between 2 and 3? 2.5, right? And now we need to figure out, okay, which side of 2.5 is square root of 5 going to sit? Well, we need to find out what is 2.5 squared. What is 2.5 squared? Come on, really quickly, tell me. $6.25. So the square root of 6.25 is 2 and 5 tenths. So which side of that interval from 2 to 3 does my radical 5, square root of 5 sit? The left interval. So from what two numbers? 2 to 2.5. So it's going to be here. And what is halfway? 2.25. Now, can you guys punch that into your calculator and tell me if that was a good estimate? What is it?
2.236067977.
All right, we good? I'm going to finish this lesson, so don't ask me to go anywhere until this is done. We have some time at the end of the class. So, moving along. Here's what I need you guys to do next. Juanita bought 40 tiles on sale. Okay, think about the key concept I brought up and I backtracked to. They measure a square foot each. What is the largest square bathroom floor she can tile? Think about what I showed you earlier. Back to this problem. Right? She needs a square bathroom. How do we find the length of these squares? We did what? We found the square root, right? But these were perfect squares. Do we have a perfect square if we're using 40? She's got 40 square tiles, square foot tiles. We're trying to figure out what's the biggest bathroom, square bathroom she can tile with those 40 tiles. So how are we going to estimate that? We need some benchmarks. We need some perfect squares. Nicole, please put that away. Give me some numbers. I have my number line. Okay. I heard 36, good. So square root of 36. And what is the square root of 36? 6. So what's my other end of my interval going to be? 49. So square root of 49. And that's 7. And then halfway is what? 6.5. Okay, we need to figure out which side of 6.5 does 40, square root of 40 sit. Well, what's the square of 6.5? What is it? I can't hear you. Can you speak up? So the square root of 42 and 25/100ths is 6.5. Now, which side of that interval does the square root of 40 sit? You're saying the left interval? Okay. So what are we going to estimate that to be? Nice. 6 and 25/100ths. Punch it in your calculator, see how close we are. What did you guys get when you put it in the calculator?
6.3245553.
And it goes on because there's only so many digits that'll fit in the calculator. So what type of number is this? Okay, it's non-terminating, non-repeating, irrational. All right, so guess what? She decided that's too small of a bathroom. So now, Juanita now has bought twice the number of tiles. So how many does she have now?
80.
She's got 80 tiles. So we're trying to estimate the square root of 80 so we know how big her bathroom can be with 80 tiles.
It's supposed to say suppose.
Okay? You don't have to make a pretty number line, but you should definitely use that strategy on your own. You're going to see it on the quiz on Monday because that's when we're taking this quiz. Tomorrow is the quiz for lesson 4, and then the lesson 7 quiz will be on Monday. Who can tell me what the benchmarks we're going to use?
72.
I heard 81, and I agree. 81. So square root of 81 is what? 9. And what's the other one?
72.
72. What's the square root of 72?
Oh,
Square root of 64. And then what's the square root of 64? It's going to be 8. What's halfway between 8 and 9? 8.5. Let's figure out what is the square of 8.5 so we know what to put above it that's equivalent. Come on, what's the square of 8.5?
72.25.
72.25. The square root of that equals 8 and 5/10. Now, which side of the interval will my square root of 80 sit? The right side, good. So what are we going to estimate the square root of 80 to be? What is it? 8 and 75/100. Can you guys tell me what is that going to be? What's the square root of 80 when we punch it in our calculator? Can you punch it in? I'm hearing too many different numbers. Okay, so not quite as good, but still pretty good estimate. All right, so did I already show you this chart? Okay, so here we have in the right-hand box. All right, so an irrational number is a number that cannot be written as a ratio of two integers. Remember, rational numbers were numbers we could write as a fraction, right? Okay, as decimals, irrational numbers neither terminate nor repeat. So if we have an irrational number that's a decimal, it's non-terminating, non-repeating. Okay. The diagram below summarizes these relationships. So if you take a look at here, do you see what that number we talked about yesterday that's in the irrational examples? It's right here. So for irrationals, we see pi, right? And we didn't use pi to calculate circumference and area. We used an approximation of pi, right? What was the number we used for pi? Just 3 and 1400ths. Close enough. It's not pi, though. It's an approximate value of pi. Pi is an irrational number, and you'd never be able to finish writing pi because the number goes on forever, non-repeating. Now, if you look at over here, do you see these square roots? Are any of these square roots perfect squares? No. None of them are, right? There is another number you'll eventually learn about, e, natural log, that comes down the road. We'll learn about that later. Now let's go backtrack over here. On the left, we have rational numbers. And rational numbers are any numbers we could write as a fraction. And if you look, they have some examples of rational numbers. Actually, every number inside of this is a rational number. But if we think in more general terms, a rational number can always be written as a fraction. And it can be negative, right? So here we have a half. Here we have negative 2/3. And can I write this decimal as a fraction? Right? I could write it as a mixed number. Isn't it 2 and 1/4? But 2 and 1/4 is the same as what? 9/4. So I just rewrote that as a fraction. So that is a rational number. Now, inside of this outer circle, we have integers. Integers are more specific. Integers are what? Look at the example, see if that helps you out. They're what? Negative and positive what? Whole numbers. Do you see integers are negative and positive whole numbers? Now what about natural numbers? Positive what? Whole numbers plus what other number? 0. So 0 and all the positive whole numbers are natural numbers. Got it? Okay. Now we got to go through and identify some rational or irrational numbers. So if it's rational, I'm going to circle it in green. If it's irrational, I'm going to circle it in red. So square root of 14. Rational or irrational? Irrational, because that's not a perfect square. So it's going to give you a decimal, and it's not going to terminate. It's not going to repeat. What about this middle number? Is that rational or irrational? Irrational. They're trying to trick you, right? Is there a pattern here?
Yes.
There is. What's happening?
The 2.
First there's a 2, and then there's 2 2s, and then there's 3 2s. That's a pattern, but it's not repeating. It's not. I can't take a block of numbers, make a stamp of those numbers, and then stamp out the rest of the numbers. You guys understand? So this is not rational. How about this number? Is this rational or irrational? It is rational. Why? Can I write it as a fraction? Yeah, I can write it as a fraction. What would the fraction be? Negative what? 98 over 100. So that is rational. Okay, more examples. First number, rational or irrational? Irrational. That's not a perfect square. And so that will give me a non-terminating Now repeating decimal. What about this next number, rational or irrational? That is rational. How about this number? That is rational. Can you guys punch into your calculator 2 divided by 3? 2/3? Right. So I can write that repeating non-terminating decimal as a fraction 2/3, right? Here's another one that they try to throw at you. Type in 1 divided by 3, 1/3. What is that? 0.333 repeating. That is a rational number also. So how about this last number, 1 2/7? That is rational. Can I write that as a fraction? And what would the fraction be? 9/7. Okay, that is rational. Okay, almost done with the lesson for the day. The square root of the blank of a square is the same as the length of one side of the squares. Square root of the... Think about what we did with the boxes earlier. What is that? What did that represent? What did that represent? Over here. What is this? 36. What is 25? How many boxes did I have in this dimension 6 by 6? If it was 6 feet by 6 feet, that would be 36 square feet. What would that be? What do we call that? The area. What do we call 25 over here? The area. If I take the square root of the area, don't I know the length and the width of the square? Area of a square is the same as the length of the side of the squares, right? Okay, if you double the length of each side of a square, what happens to the area of the square? So now we're going to start to see some patterns. So first of all, I need a square. And let's start with an easy square. 2, or let's do odd numbers. Let's say 3. So I have a square whose height and width is 3. So what would the area of that square be? 9. And it says, hey, we're going to double the length and the width of the square. So what's the new square's length and width going to be if I double it? It's going to be 6. So now I have 6 squared. What is 6 squared? 36. Okay, so now I'm going to double my square that was 6 by 6. What's the new square's dimensions? 12 by 12. So if I find the area of that square, what's it going to be? 144. Do you see a pattern emerging? So if I double the side, I quadruple the area, or I multiply each by 4 to get the area of the next one. So now, determine whether or not each decimal has a repeating pattern. Does this have a repeating pattern?
Yes.
Can I take a block of the numbers, make a stamp out of it, and finish the rest of the number? I can. So this repeats at 3, 4, 2, and then it repeats 3, 4, 2, 3, 4, 2. So that is repeating. Does this one repeat? Is it a pattern, though? You don't see the pattern?
Yes.
There's a pattern, but that's not the same as repeating. This is not repeating. What about this one over here? This one's not repeating. 10, 11.